Hello there, welcome to the June 2019 core paper 2. Here we're looking at question 7. Find the values of k for which the matrix has an inverse. So that means it's not going to have an inverse for one certain value of k for which the determinant will equal 0, but we just need to find the values, and it's not going to be that value. So the determinant of m is going to equal 2 times minus k minus 8. And then it's going to be plus 1, lots of minus 3, minus 12. And then it's going to be plus 1 lot of 6 minus 3k. So the determinant equals minus 2k minus 16 minus 15 plus 6 minus 3k. So it's going to be minus 5k. And then simplify this would be minus 25. So therefore, k should not equal 5, because then that will make the determinant 0. So there we are, k should not equal 5. No, minus 5. Because then the minus double minus will make it 25, so it's k should not equal minus 5. Okay, so moving on to part B now. Find in terms of P the coordinates of the point where the following planes intersect. So in this case here we have K is equal to 6 from the matrix before. So what we'll do then is we'll turn this into a matrix problem. 2, minus 1, 1, 3, minus 6, 4, 3, 2, minus 1, lot of x, y, z equals P10. Now this question here is worth 5 marks, so that's an indicator to me that they'd probably like us to work out this inverse by hand. So we'll call this matrix A. So the matrix of minors of A is going to be equal to, let's do cross out the row, cross out the column, so it's going to be 6 minus 8 is minus 2. Moving on to the next one, cross out the row, cross out the column. That's going to be minus 3 minus 12. That would be minus 15. Cross out the row, cross out the column. That would be 6 minus minus 18. So 6 minus minus 18 would be 24. Cross out the row, we're on there. Cross out the row, cross out the column. So on the middle left-hand one, so it would be 1 minus 2 is minus 1. Middle, it would be minus 2 minus 3 is minus 5. Cross out the row, cross out the column on the middle right, that's going to be 2 minus minus 3, that would be 7. And then cross out the row, cross out the column on the bottom left one, minus 4 minus minus 6, that would be 2. Cross out the row, cross out the column on the middle bottom one, that would be 8 minus 3 is 5. And on the bottom right one, it's going to be minus 6 minus minus 3, minus 12 minus minus 3, that would be minus 9. Now we're going to transpose it. So it's going to be minus 2, minus 5, minus 9. And then transpose it will mean minus 1, 2, and 5 will end up here. So they will cross over the leading diagonal. Minus 15, positive 24, and then 7. Now we'll do the cofactors. The cofactors are the plus minus plus minus plus minus matrix. So it's going to be minus 2, 2, minus 5, 24, minus 9, and then the other ones have their sign reversed. So it'd be 1, 15, minus 5, and then minus 7. And then it's going to be, the answer to A inverse is going to be 1 over, now what was the determinant back here? It was minus 5k, minus 5k minus 25. In this case here, k was 6, so it'd be minus 5 times minus 6, that would be 30, minus the 25 would be 5, so it'd be 1 over 5 times minus 2, 1, 2, 15, minus 5, minus 5, 24, minus 7, minus 9. So now, to find, in terms of the constant p, where the planes intersect, we apply the inverse matrix to the other side. So therefore, now that we've found the inverse, it's going to be x, y, z. This will be the coordinate of the planes intersecting, times minus 1 over, so 1 over 5, minus 2, 1, 2, 15, minus 5, minus 5, 24, minus 7, minus 9, times by p1, 0. So this is going to be 1/5, I'll leave the fifth at the front, of minus 2p plus 1. The next bit's going to be 15p minus 5, and the next bit's going to be 24p minus 7. That will all be over 5, so therefore the coordinate's going to be minus 2p plus 1 over 5. Next one's going to be 3p minus 1, because we can divide that one by 5. And the next one's going to be 24p minus 7 all over 5. So there we are. That will be the coordinate where all the planes intersect in terms of p. And moving on to part C, part I is find the value of q for which the set of simultaneous equations of this simultaneous equations here can be solved. Now what it means by can be solved is that in this case here, where we have k equals minus 5 from before, if we look back at our matrix here, we said that k could not equal 5, so therefore there's no chance of making an inverse out of this matrix here. What it means is that these three planes here are going to intersect along the same line, or in fact this is going to make a sheaf. So for this value of q, interpret the solution of the set of simultaneous equations. I know the answer to part I already. There's no parallel planes between these two planes here, are no identical planes, so this will form a sheaf. So I know the answer to part II already. I just now need to find a certain value for q for which it will form a sheaf. So let's now, let's just get rid of that circle there, that's a little bit in the way. So now I need to find a way of cancelling out one of the letters here in the simplest way. I think I'll cancel out the z's in the simplest way here. So in the first case, if I call this one equation 1, this one equation 2, and this one equation 3, I'm going to do equation 1 multiplied by 4, take away 2. Okay, so be very careful here. Times equation 1 by 4, and then take it away from take away 2. So it's going to be 8 minus 3 is 5x. Then it's going to be minus 4 minus 5y. That'll make it y. And then it's going to be 4 minus q. And then I need to do that in a second way. In the second way, I'm going to times equation 3 by 4, but then add it onto equation 2, because the z's, one is a plus, one is a minus, so we add to cancel them out. So it's going to be times 4, times 3 by 4 is 12, add it onto 2, which will make it 15x. Then it's going to be plus 4 lots of this is going to make it 8, then add minus 5, that'll make it 3y, and then it's going to be 4 lots of this, which is nothing, add this, which is q. So therefore we can see that there is a scale factor from one line to the next of a scale factor 3, so therefore 3 lots of 4 minus q should also be equal to 3, so equal to q. The reason being is that for our planes to have a solution, we want to form a sheaf, and therefore this equation here and this equation here need to be identical. They're just a scale factor away from each other, where if you times the top one by 3, you get the bottom one. And that must be the same for the number on the end. So that's going to make us 12 minus 3q equals q, so therefore 12 equals 4q when you add the 3q onto the other side, so therefore q equals 3. So q equals 3 is the answer here. So when q equals 3, the three planes form a sheaf. They intersect along a shared line. They intersect along a common line. And there we are, that's the answer for question 7 there, worth 11 marks in total. Let's now move on to question 8.